Alrighty, good afternoon, everyone, and welcome to another Aquarium Online Academy. My name is Tina. I'm one of the educators here at Aquarium of the Pacific, but I am not alone in my studio today. I am joined by my very good friend Talia, who is behind the camera right now. Talia is going to be controlling all of the wonderful magic that you see behind me, and I believe we also have Lourdes in the corner over there for my emotional support. She will be joining us today as well. I have an awesome program to teach you all today. We are going to be talking about one of my absolute favorite habitats of all time. We are going to be talking about the deep sea. But while we are talking, while we are learning and engaging today, I want to hear from you. You are more than welcome to text us in with observations, questions, comments. If you just want to say hi, I would love to hear from you. You can text us at 562 286 1838. Talia is actually monitoring that phone line, so I would love to hear any kinds of questions or observations that you might have about whatever it is that we are going to be talking about. That is if you are watching us on May 22nd. I believe it's the 22nd today, at 3 o'clock Pacific Standard Time here in Southern California. But if you are not watching us live at this point in time and space, you can still engage with us during this time watching the program. You can email us at live@lbaop.org, and one of my coworkers actually monitors that email chain as well, and we will get back to those questions and observations that you have. So Tali's going to keep this up during our program today. So again, please feel free to text us in with anything that you would like to tell us. But we are going to get started. We're going to start by making some observations. We're going to be warming up our scientist brains today. We will be making observations of the screen behind me. This is actually one of the habitats that we have here at the aquarium. These are our Japanese sea nettles. I think they are absolutely gorgeous. Our jellies are some of the favorite animals that I have here at the aquarium. When we do observations, we use our sense of sight. We use our eyeballs, we take a look around our environment, we look around at where we're at, and then we take notes in our brains. We take some notes about what we're seeing, maybe what we're feeling, what we're smelling, maybe, or maybe any other sense. I want you to use your brain, take some notes, use your eyes, make some observations about the screen behind me. I'll go ahead and step off. If you do have those observations, I would love for you to share with me what it is that you are seeing. And you can do that by, again, texting us at 562 286 1838. Once we get those observations, Talia will spread those messages over to me, and I will answer them live on the air. Again, anything that you're noticing, any kinds of observations, it could be shapes, it could be a color, it could be maybe how these animals are moving. Jellies aren't like typical animals that you might see in the forest or here on land. Even some animals in the ocean, they move very differently. Or maybe you want to share a fun jelly fact. I love jellies. I think there are so many things that we still don't know about our jellies, just like the deep sea. There is a lot that we don't know. All right, take a couple more seconds. What do you notice? So right off the bat, I notice a particular color pattern. I'm noticing that the top portion of our jellies are this really bright, almost yellowish orange color. That's pretty similar for all of them, but their tentacles underneath them are a little bit of a different color. I'm also seeing two different types of tentacles that these jellies have. I'm seeing some that are really, really long and thin, almost like string. And then I'm seeing a couple that look like ribbons. They're very curly. They're very kind of jumbled up together. I can also see how they're moving. I'm going to kind of equate this to an umbrella, opening and closing. That top part of their body, we call, I'll use this one. We call this the bell. So the bell of our jelly is in charge of moving it throughout the water column, but also opening and closing as well. There are a bunch of different species of jelly. You'll find jellies in almost any ocean here on our planet. They can live in a bunch of different kinds of climates. What's amazing about jellies is that there are even some jellies that live within the deep sea. Now, what we're going to be doing is taking a look at a couple of adaptations of animals that live in the deep sea figure out what they have on their body in order to survive. Do we happen to have that word? I would love to see how it's spelled. Let's see if I can make it magically appear. Ah, and I can. So this is adaptation. An adaptation, a new word for your word bank, is something an animal has on their body in order to survive. For example, for our jellies, they will have these wonderful tentacles, these wonderful stinging cells to help them survive. Those two that I mentioned, those two different ones that I just mentioned before, serve two different purposes. The really long ones that look like strings, those are their stinging cells. So that is what helps them to sting their food. And then the ones that look like ribbons, those curlier jumbled up ones, those are their oral arms. So that helps them to actually grab their food and pull their food into their body so that they can start digesting it. That is an excellent adaptation that these animals have. Us humans, we have a lot of adaptations as well, just like, what are these? Just like our hands. We use our hands to grab onto things, to maybe climb. We can write with our hands. We can eat. We can even communicate and say hello to our friends, say thank you to our friends as well. Really important tool that we humans have, the hands on our body. But not every single animal has hands, right? Does our jelly have hands? I don't think so, but I do think they would get a lot more done if they did have hands. But we'll keep this word in our word bank for now. We are going to transition and talk about some of the amazing animals of the deep sea. I'm going to have, big jelly friend coming over to say hello. I'm going to have Talia surprise me with an animal from the deep sea. Let's see which one Talia wants to talk about first. I wonder. There are so many cool ones, it's almost really impossible to pick. I have a deep sea favorite. I don't know if Talia can read my mind. Talia, how did you read my mind? Oh my goodness, that's amazing. She said, I guess. This, my friends, is a flower hat jelly. This is actually a jelly that we have here at the aquarium. They are absolutely stunning. Right now, you are seeing them in a beautiful fluorescent, or giving off a beautiful fluorescent light. So there are two different kinds of, I'll say, glowing light that you can encounter in the deep sea, a fluorescence and then a bioluminescence. For these animals, if we did not have that fluorescent light kind of shining on them, you would be able to see more of a clear jelly with these green stripes actually being more of like a reddish, almost pink color. Color is very, very important within the deep sea. So, a couple of adaptations that this particular jelly has is in that fluorescent light, they're pretty much able to disappear, or without that fluorescent light, I should say, they're pretty much able to disappear. Because as I mentioned, color is very, very important in the deep sea. When we think about the deep sea, what are some properties or characteristics that first come to mind? If I told you deep sea, what's the first thing in our brains? Maybe the fact that it's deep, right? That could be the most obvious one, that it's really, really deep down there. Maybe, what are we seeing in the background of this picture? Nothing, right? Our deep sea is going to be very, very dark. That's because it is very, very deep. Do you think that the sun is able to shine its light all the way down into the ocean that deep? I don't think so. Light has a hard time traveling really, really far down in the ocean. So when you look at ocean animals that live inside of the deep sea, they're going to want to be a very specific kind of color. Now, this all has to do with the spectrum of color. There are some colors that can be seen pretty well in the deep sea, others not so much. I don't know if we have a picture of that graphic. I don't know if you know which one I'm talking about, Talia. The one that shows the colors in the deep sea? There's a chance that we might not have it. And if we don't, that is absolutely okay. But what I can talk about is what colors you won't really be able to see very, very well in the deep sea. The color of this jelly, we are seeing, what do you think? I kind of gave it one way before. I see those green dots, right, along those tentacles. I'm also seeing that this body of our jelly is one of my favorite colors. It's going to be blue. So, do you think that this animal, our flower hat jelly, if they want to hide from predators, do you think that they would want to be a really, really bright, easily seen color, or a color that can blend in a little bit more? Give me a little this if you think blend in. Give me a little this if you think stand out. I think our animals are going to want to blend in. Once we pull up some more pictures of deep sea animals, you'll notice that most of them, their actual bodies, are going to be more of that red color. But when they want to either protect themselves or when they have that fluorescent light on them, they're going to shine, or parts of them will kind of show blue. Blue is a color that can be seen relatively well inside of the deep sea. So remember when I said this animal is actually going to be more of like a pinkish clear color? That clear, that pink, absolutely gone inside of the deep sea. I'm wondering, Talia, maybe do we have another picture of an ocean, undersea ocean animal? Undersea, deep sea ocean animal. Because we're going to talk a little bit about that bioluminescence. We're going to talk about how that could actually help some animals survive, how certain animals might use that bioluminescence as an adaptation to help them survive within the deep sea. Let's see what wonderful animal Talia has. Oh, Talia knows that I like jellies, so we're talking a lot about our jellies today. So this is our, I've heard two different names for it. I've heard alarm jelly. I believe that's what we're calling it here at the aquarium. This one is our alarm jelly because I kind of think it looks like a little bit of an alarm. I would be alarmed if I saw it. No, no takers. I thought, thank you. I thought that was kind of funny. But this animal right over here, our alarm jelly, what color are we noticing? We also see blue. Can blue be seen in the deep sea? Absolutely. So they will use that blue color very similar to an alarm to warn off or scare off predators. What shape are we noticing here on our jelly? What do you think? You can show me with your hands if you would like. I know I can't see you, but I'm there in spirit. A circle! Absolutely. Same with a lot of our other jellies. They're also this very similar circular pattern, circular shape. Now, I want to show you a video of an experiment that we actually do sometimes in our classroom programs that we have here at the aquarium. We use a kind of a dried out version of an animal called an ostracod. These interesting animals are able to use this bioluminescence, this blue color, to their advantage. I'm wondering, Talia, are we able to pull up that video of said experiment? No, no worries. But my friends, I want you to think of maybe not a deep sea animal. I want you to think of another animal that's able to protect itself by shooting out something, a cloud of something. What animals can kind of spit out a cloud of something? The animal that comes to my mind first is an octopus. Octopus, while they don't live in the deep sea, they can live in a couple of different habitats here in the ocean, but they are able to shoot out ink. When they shoot out that ink, they are actually preventing their predators from finding them inside of that dark cloud. What we're seeing right now is a bowl filled with, I don't know if you can see these little brown things. Those are the ostracods. Right now, our scientist has crushed them up. We have just turned off the lights. I will step off screen. Once they add water, watch what happens. What are we seeing? What are we seeing? What are we noticing? What color do we see? That's right, my friends. We're going to see that blue. You can see all of the ostracods, I believe I'm pronouncing that correctly, inside of that water moving around. I think that is absolutely incredible. So these animals are able to produce that blue cloud of bioluminescence to scare off those predators, very similar to how our octopus is able to use their ink. Now, there is another deep sea animal that is able to do this as well. I'm wondering if we can pull up a picture of that same animal. It's also relatively tiny, that's able to use this blue cloud of bioluminescence to protect itself. I think we know. Yes, perfect. So we're noticing that this animal, which is a, what do we think? Shrimp, one of my favorites. This shrimp is spitting out that bioluminescence to scare off a predator, to give itself some time to escape. And what color is their body? What are we noticing? Do we remember what we mentioned before about what colors can and can't be seen in the deep sea? Red. That is right, my friends. So the body of this shrimp is a red color because they want to blend in. Very, very good. To the deep sea. Red is not able to travel down that deep into the deep sea, just like our sun. Just like that beautiful sunshine. It's not going to be able to go all the way down here. An incredible adaptation that these animals have is having this red body to help them hide, but also using that bioluminescence. Oh, so sorry. Need to move my mic just a little bit closer to my mouth. Oop. I hope everyone can hear me just a little bit better. Alrighty, my friends. So they're using this bioluminescence to give them some shelter, to give them some protection from any kind of predator. Let's see if Talia can surprise me with another animal that calls the deep sea home. And let's see if we can find any similarities between a couple of these animals too. I'm wondering if some have similar adaptations, if they have some different ones. Make some predictions. What do you think? Which one do we think we're going to see? Who is this? Oh my goodness. What's the technical name of this creature over here, Talia? Bobtail squid. Thank you. I knew it was a kind of a squid, but the specific kind of squid this is a bobtail squid. Look how cute they are. They are absolutely adorable. Are we noticing some similarities on this animal with the other animals or other adaptations that we talked about? I think there's at least one thing that this animal has in common with the other animal that we just took a look at too. What color is their body? I'm seeing some white, but I mainly see red. Again, is this a color that we can really see in the deep sea very well? No, not at all. So this animal is basically going to be camouflaged in the deep sea. Camouflage is an adaptation that many animals use in order to help them stay protected. It helps them to hide from predators. For some, it could help them hide from their prey so that they could sneak up on their prey. But in this case, for our bobtail squid, these animals are relatively smaller, so they will be protecting themselves. It looks like we might have a couple of questions. Oh my goodness, I love questions. So we have a question from Karina. Karina, thank you so much for your questions. How do jellies hold things? Excellent, amazing question. So we noticed that jellies don't really have arms like we do, right? And they don't have hands like we do. So they can't necessarily grab onto things like a seahorse tail could and hold on to different items. They are what we call drifters. Being a drifter means you go with the flow, man. That's why I love jellies so much. They go wherever the ocean takes them, and they don't have much say about where they go. So they can't really hold on to things, except for that flower hat jelly that we were taking a look at earlier. They have the ability to perch themselves almost on different kinds of rocks, which I find very interesting, by using kind of those sticky tentacles that we were looking at before. Amazing question, Karina. Thank you so much. Someone had asked, do they sting? I'm assuming that's referring to our jellies. Our jellies can, in fact, sting, especially those Japanese sea nettles that we were looking at before. The longer the stinging cells, the more powerful that sting is going to be. Now, we do have some jellies here at the aquarium that sting, but they don't have a sting that we could feel. So it really depends on the species of jelly, but also the size of their stinging cells, those tentacles as well. Now, Chase has asked a very good question. Chase, what makes jellies bioluminescent? That is an excellent question, Chase. I'm going to step off really quick because I might have to tape my mic over to my face because I think our sound is just a little bit low. This is bringing me back to my days in the theater. Give me 1 second, Chase, and I will answer that question for you as we fix our mic. Oop, try not to get it stuck onto my hair. Okay, it is taped onto my face, so I hope that we are able to hear me just a little bit better. Alrighty, Chase, what makes jellies bioluminescent? This is an incredible question. I also want to talk about this squid here. Let's come back to this squid and let's jump back to a jelly picture really, really fast. Any kind of maybe that we can talk about the flower hat jelly actually. Perfect. Excellent. So, we are back to our oops, sorry. Excellent. We are back to our flower hat jelly. So, to kind of combine the question with Karina, this is what I was talking about, those arms, those little not really arms, those tentacles that grab onto things. Our flower hat jelly is allowed to or can do that. But essentially, jellies have certain jellies have some kind of chemical in their body that allows them to produce this kind of color. But this jelly isn't bioluminescent, it is fluorescent. So it is able to react to lights that are put on it, as opposed to that shrimp that is able to produce bioluminescence, if that makes sense. I'm trying to get the pronunciation of this chemical correctly for you, Chase. Hang on. Give me 1 second. From what I'm seeing, it's luciferin. I feel like I might be pronouncing that correct. Oh, Talia's giving me the thumb up. Luciferin is the chemical that most jellies have in their systems in order to produce that kind of bioluminescence. That is a wonderful, wonderful question. Keep those questions rolling in, my friends. I think Talia is writing down possibly another question, but I would love to jump back to that bobtail squid picture to talk about that one. Oh, before we run out of time. Excellent. So, another adaptation that a lot of deep sea animals will have, or at least animals that live inside of darker areas, they will have very large eyes. These large eyes help them not only to see in the dark, but also see relatively far. Some of this can be true for even animals that just live in the open ocean that's not as dark, but there's so much space they need to be able to see far. Now, there's one more animal picture I definitely do want to talk about. I pulled it up on our second computer. It's of a very cute little fish. It's a friend that has a little light on their head, or another friend that has interesting textured skin. I'll let you choose, Talia. Maybe we'll do both. If I'm feeling crazy, we might do both. Anticipation. I love this fish. Does anyone know what kind of fish this is? This, my friends, is an anglerfish. Give yourself a pat on the back if you knew what kind of fish this is. There are a couple different types of anglerfish within the anglerfish family, but the most notable anglerfish are the ones that have a little light right on top of their head. I say light, it's not a light bulb, but again, it's going to attract prey into their mouths. We call this a lure. Almost like if you went fishing and sometimes you need to put bait on a hook. Sometimes you might have little fancy things on your hook on top of the bait. That's your lure. Our fish in the ocean do the same exact thing. Notice the shape of their mouth as well. It's shaped like a U, an upside down U. That way, if there is a fish swimming over here, what's the best way for me to do this? If I walk, nope, I'll walk this way. So, if my hand is a fish and I'm swimming over to check out this lure that's right here, the anglerfish's mouth is at the perfect angle for it to swim upwards and straight on over to the fish or the prey that they are trying to eat. Now, notice the color as well. It's just as dark as the deep sea, which I love. Do we have any other little anglerfish pictures or frogfish pictures on that computer, perhaps? Let's see. I know there have been some famous stories about anglerfish. Most recently, how some can surface, but surfacing can be hard. for some deep sea animals. Not only is the deep sea deep, it is dark. And there's a lot of pressure down there. Do we think water has weight to it? Absolutely. Have you ever tried to pick up a bucket of water? That's really, really heavy. So when all of that water is stacked on top of, yes, thank you, Tommy. Once the water is stacked on top of an animal like that, their bodies need to be able to adjust to that pressure. That's why us humans aren't really able to go down to the deep sea to discover it because our bodies aren't built for all that pressure. We would get flattened like a pancake. That's why ROVs, remote operated vehicles, submarines are so important and helpful for us to be able to discover all of these incredible species that live in the deep sea. So, if a fish like this were to surface, all of that condensed body that they have could just expand. Hence why we know the blobfish looking so funny the way that it does. The blobfish picture that we think about kind of looks like this animal over here a little bit. We think of it as a big pile of bubble gum, almost, is how I'll describe it. But in actuality, that blobfish looks very similar to this fish over here. Looks plain old normal fish when it's in the deep sea because it has all of that pressure to hold its body together. This, my friends, is another fish, a little toadfish that lives within the deep sea too. And what color is its body? Red. Absolutely. So do you think it can be seen in the deep sea? No, it cannot. I'm also noticing that it has little spines all over its body too, and I'm wondering if that can also help protect themselves, very similar to a sea urchin. Now, I just mentioned before how important it is to discover different things about the ocean within the deep sea. With my last couple minutes or so, up to Talia, whatever kind of video or picture you would like to throw up about us, throw up, if you would like to put on about how we humans discover the deep sea, that would be wonderful. There are a couple of different ways, some via submarine, as I mentioned, but that kind of limits us because submarines can be hard to navigate if you're under the water. So a lot of the times we will resort to remotely operated vehicles, very similar to this one, where someone will be on a boat on the surface of the water, controlling an ROV, a little, almost like a, think of it like the Mars rover, but under the sea with a controller, similar to a video game as well, kind of. That helps us map our ocean floors and discover all of these intricate, amazing species. We have only discovered about 8% of the ocean. That's not a lot, right? Our oceans cover about 75% of our planet. We are more ocean than we are land, and we don't even know what goes on down there. That's what fascinates me the most about the ocean. That's why I love the ocean so much, because we've explored more of outer space than we have on our own planet, which is just mind boggling. The deepest point in the ocean, I'm wondering if anyone knows. Chat, type in if you know. What the deepest part of the ocean is. It is a specific trench, and it is called the Mariana Trench. Mariana's Trench is about 7 miles deep. When I say 7 miles, I know it doesn't sound very deep, but that's larger than Mount Everest. Correct me if I'm wrong. But think of Mount Everest, but upside down as well. We might have another question coming in as well. Oh, we have one class watching. Oh my goodness. Hello to my classroom friends that are watching. Oh, it is so good to see you. I love having our classes on our AOAs, on our Aquarium Online Academy as well. And I'm wondering, my friends from my class, if you are able to text us in. How many students do you have watching today? We're always trying to make sure that we are reaching our wonderful audience, reaching all of you. So feel free to text us at 562-286-1838. Let us know where you're watching from. Let us know who your teacher is. Are you having fun? And how many kids you got with you today? How many explorers do we have? Now, my friends, I believe I am all done and out of my time. I could keep going and talking about the deep sea forever. But just to recap, we talked about adaptations of our animals. We talked about what on deep sea creatures helps them survive. One, most importantly, being their color. Not all colors can be seen in the deep sea, especially red. So a lot of the bodies of our animals in the deep sea are going to be that red color so they can blend in. A lot of the bioluminescence that we were looking at is a blue color because blue can be seen pretty well in the deep sea. We have limitations of exploring the deep sea like pressure, right? How deep that water is. Humans can't really travel down there, so we need to rely on remotely operated vehicles and some submarines to help us navigate, help us map the ocean floor to see what's going on down there. Now, my next generation of scientists, this is on you too, my friends. It is now your turn to help us discover the rest of our oceans, figure out if there are any other species of animal that might be hiding in that deep sea that we don't even know about yet. Right, my friends? Thank you so much for exploring with me today. I had so much fun with all of you. I hope you can join us for our next Aquarium Online Academy, which will be the following week on Tuesday at 9 a.m. Pacific Standard Time. We cannot wait to see you there. Again, feel free to email us if you are no longer watching us live. Again, my name is Tina. Thank you to Talia and Lourdes for helping me out today. Have a wonderful rest of your day. Be kind to one another. Be kind to our planet, my friends. Bye bye.